Demonstration, I have a I-beam model. It has holes cut out. The holes are actually, bolt holes to connect this I-beam to other components in an assembly. And I want to focus on in this demo is how to create a portion of that connection in the assembly. I have the master part shown here as a solid body, and I've got an idealized part. It has mid-surface features, and then it also has 8 points. If I look at one of those points, edit, and it'll say, well, I'm a point on a circle, arc, ellipse, sphere, center. So I'm at a point at the center of that circular edge. When that edge updates, the points will update as well. And look in my FE model, I'm a shell mesh. I've got points at those center points, and those points will update. But what I want to do next is create a spider element, or not just one, but a set of spider elements using 1D connection. And can't use, say, point to point, point to edge. I can't use point to face. If I select a point in this command, it only lets me pick one, and then I can pick a face. It doesn't let me connect to some of the nodes on the face. It'll connect to all the nodes on the face. But imagine I've got one face here, and it's got 4 points that I want to define a connection at. Now I don't want all the points. I just want some of the points about that hole. And 1D connection node to node has a proximity spider where I can use this distance. So the trick here is to be able to have an editable set of spiders, in as quick or as efficient a manner as possible, and something that's updatable. So I'm actually going to do this using selection recipes for my source selection and my target selection. So let's go back out of here and look at my selection recipes. In my model, I've got 2 stacked selection recipes. This first stacked selection recipe, selecting all the faces by attribute. So I've got 31 faces in this model. If I look at this first rule, it's selecting faces by name, and I'm using the wildcard. Essentially, it's finding all the faces in the model, and then I'm finding the related nodes. And if I show that, it finds all the nodes in the model related to faces. It's not finding, well, I don't yet have nodes on these points, but it wouldn't find the nodes on the points. It would just find the nodes on those faces. And then I've also got a nodes on point selection recipe, and you can see that it doesn't find anything yet. No entities are in the selection recipe. So let's do that. We'll take a look at the edit, and you see it finds the same strategy. I want to find it's by attribute. It gets 8 of them, but then it looks for the related nodes, and it finds there are none. So now I want to create those nodes on those points. There's 2 ways that I can think of to do that. One would be using the the node on curve edge command. So this will let you associatively create nodes on points, edges, or curves. And so if I select a point, maybe I want to pick more than one point and I want to area select. Well, it won't let me area select. It'll only let me pick an individual point at a time. I'm going to select one point, I get a node. I select another point, I get another node. But imagine I've got hundreds of points in my model. That's kind of inefficient. So I'm going to go ahead and cancel this. But now I do have 2 nodes on points that are associative and will update as those points update. Another thought is, well, I can use the 0D mesh command to generate my nodes. And then what this lets me do is select as many points as I want. So if I say select all, I get 8 of them, and then I'll select or shift select here. I got to shift select those two. So now I've got six points selected on the points that don't have nodes yet. I'm going to create a mass element. It's really not going to matter because I'm not going to use that mass element in my model. The next thing I do is edit the mesh associated data, and I say I don't want to export that mesh out. So I'm not going to get those set of lump masses in my solve, but if I use the node created by that mesh in another mesh, then I'll get that node and I'll get that other element associated with that other mesh. So let's go create that other mesh right now. I'm going to turn off, say, the 2D mesh right now, and I'm going to create a 1D connection. It's going to be a node-to-node method, and I'm going to use this editable node-to-node connection. This is something new in 22.12. So let me modify a connection that's being defined with nodes, and it'll also update as my updates. I'm going to use the proximity spider method, as I stated earlier, and then I'm going to use, for my source selection, instead of using a node or a set of nodes, I'm going to use a selection recipe, and that selection recipe now is the node on points. You can see it now has gone from red to black, meaning there are nodes associated or found by this recipe. And then target, I'm going to pick my nodes on faces and then all the shell mesh nodes in the model. But then I'm going to limit that search to 7 millimeters about each point in my source list. I'll go ahead and create an RBE3 here. And now I just edit the display, make this black, might stand out a little bit more. So I can see my spider elements there. In the context of the 2D mesh, you can see how far they go out in the context of the 2D mesh. All right, so that's the creation of those connections. Now let's see how well they update. I'm going to go back into my master part, and I've got this move face operation. I'm going to move that face up, so I'm going to unsuppress. Flange gets a little bit thicker, and the idealized part's already up to date, and the points are up to date in the idealized part. So then I switch to the fem. It updates its geometry. The points are up to date, and I just need to update my meshes. So I go ahead and hit the update button, and for some reason it's asking me to update again. I believe this was reported as an issue in 22.12, but it's been fixed in subsequent versions. And like if I turn off the 2D mesh, we can see that I'm getting my my RBE3 spiders at each of the point locations. So from the two nodes on points over here, and from the 6 lump mass on points, from the other holes. So that seems to be like the most efficient way for us to create proximity-based spiders in a model where you have n number of spiders from n number of point locations that you want to generate these types of elements from.